All right, on the
I'm looking at George.
test tomorrow.
Test tomorrow.
Test tomorrow.
Test tomorrow.
Chapter 6.
Test tomorrow.
Test. So, first of all, polygons. Remember, a polygon, the biggest thing is it can't have curves.
No curves.
It has to be closed, and sides can't intersect. So the first part of the test is you'll just have a figure and you gotta say yes or no, is it a polygon?
No.
So if it's got any curves, that's easy to see. If it's closed, that's easy to see. Like this would be an example of not a polygon, even though there's no curves, it's not closed.
Okay.
And then the other one to look for, sides can't intersect. This is the most common one. That's not a polygon because these two sides intersect. Okay? A regular polygon. Ever remember if something's regular, what it means? It is normal. All sides and angles. Are congruent. Okay, so a regular triangle would just be an equilateral triangle. That's a regular polygon. A regular quadrilateral would be a square. A regular pentagon would be just that, all the sides are the same. Regular hexagon, and so on. So, if it is regular, remember all the angles equal the same too. So, in a triangle it adds up to 180. So 180 divided by 3 would be 60. Quadrilateral is what we're doing. So they add up to 360, right? So they would all be 360 divided by 4 is 90. Okay, then of the polygons, what we're doing is the quadrilaterals. So, the quadrilaterals, we've got the special types, parallelograms, and there are 3 special parallelograms: the square, rhombus, and rectangle. And then the other 2 that are special quadrilaterals are a kite and a trapezoid. Okay? So, there's some of these sometimes, always, never questions. One thing you got to remember is a square could be called a rhombus, it could be called a rectangle, it could be called a parallelogram. It's just square is the better name for it. Because everything that's true in these is true in a square. So a square could always be called a rhombus, or always a rectangle, or always a parallelogram. But a rhombus could only sometimes be called a square. And that sometime would be as if they're all 90. A rectangle could sometimes be called a square only if all the sides are the same. Okay? A rhombus is always called a parallelogram because a rhombus has to be a parallelogram to be a, right? A rectangle could always be called a parallelogram. All of these things could always be called quadrilaterals. All right? Could a kite sometimes, always, or never be called a parallelogram? Never. Could a trapezoid sometimes, always, or never be called a rhombus? Never. So remember, a trapezoid only has one rule. It just has exactly one set or one pair of parallel sides. That's the only thing that's true in a trapezoid. A kite, remember, doesn't have parallel sides, it's just these two are equal and these two are equal, that's the main thing. Okay? So that covers the sometimes, always, never problems, but a trapezoid would always be called a quadrilateral. Okay? Would a quadrilateral sometimes, always, or never be called a trapezoid? Sometimes, because it could be any one of these. Then, you have to know all the properties of these. So, remember, on a parallelogram, obviously, opposite sides are congruent. Opposite sides are parallel. So the little triangle on there shows that they're parallel. Opposite angles are congruent. Opposite or consecutive angles are supplementary, right? And the diagonals bisect each other. Okay? So, the ways to prove that something is a quadrilateral or a parallelogram. Remember, this is just like ways to prove triangles were congruent. Angle side, angle side, angle side, that stuff. Ways to prove lines are parallel. Corresponding angles are congruent and all that stuff. For these, if you want to prove something's a parallelogram, one of these 6 things has to be true. So the most common is both, it has to be both pairs of opposite sides are congruent. So both pairs got to be congruent, opposite sides. Second way, it would be if both pairs of opposite sides are parallel. Both opposite angles are congruent. Again, it's got to be both opposite. It can't just be one pair of opposite sides or angles. Consecutive angles are supplementary. That means any 2 angles in a row have to add up to 180. Diagonals bisect each other. And then the last one is a combination of the first 2. If you know that just one pair of opposite sides are parallel and congruent. Shh, quiet. So if you just know that these 2 are both congruent and parallel, that would work. So it has to be one of these 6 things. If it's anything else, you can't prove it's a parallelogram. Okay?
Do you need to memorize all?
Yes, you need to know these. Okay, then of the parallelograms, you need to know the properties of squares, rectangles, and rhombuses. So a square has all this stuff true. Opposite sides are congruent and parallel. The things that's added though is all the angles are 90. All the sides are the same. The diagonals do bisect each other, but not only that, they cut each other into 4 equal pieces. These angles are bisected also. They're each cut into 45s. And the last thing is they're perpendicular to each other. So, on a rectangle, all of these things are true up here. All of them are 90. No, you just need to know all these. The diagonals do bisect each other. And they do cut each other into 4 equal pieces. They're not perpendicular, and they don't bisect the angles. And then in a rhombus, again, everything true is true up here. All the sides are equal. Opposite angles are congruent. Diagonals do bisect each other. So this piece equals that one, and this equals that. And they are perpendicular like in a square. And these angles are bisected also like in a square. Okay? Then you also need to know on a kite, these two sides are equal, these two sides are equal, these two angles are equal, the diagonals are perpendicular, put away that, and just this one gets bisected, so that's equal to that. And then on a trapezoid just has one side or pair of sides that are parallel. That's it. If it's an isosceles trapezoid, then this side equals that, and also base angles are equal. So this angle would equal that angle, and these two would equal that. That is an isosceles trapezoid. So, there's a part of the test where you're going to have a picture, and you've got to name its, what is it?
Triangle.
Okay?
Rectangle.
So if you saw this, if the sides are equal or the base angles are, you got to call it an isosceles trapezoid, not just a plain trapezoid. Okay?
Are we doing
If you see something like this, what would you call that? It's not a trapezoid because it's nothing's labeled that anything's parallel.
Quadrilateral.
Yep, this is just a plain quadrilateral. It's not a special one because it doesn't have any special properties. Oh yeah, before I forget, remember concave and convex.
Concave is when it dips.
Yep, concave is, it's caved in. So this would be a concave,
Because the rubber band, when you go around, it doesn't.
yep, it wouldn't touch there. So anything that doesn't have anything caved in would be convex then. Just about done. I think there's just one more thing I gotta go over. Oh yeah, the areas, that last assignment we just had, again, you will have a formula sheet to find the areas. So, I don't know that I gotta go over those. You gotta find the areas of squares, rectangles, kites, trapezoids. Squares, rectangles, all that stuff, that's easy enough. The one you gotta remember is a rhombus and a kite has a formula that you've probably never used before. To find the area of these two, you can multiply the diagonals and then divide by 2. So whatever this diagonal is and whatever this is. So they may just say this is 8 and this is 3. Well, if this is 8, the whole thing is 16. If that's 3, the whole thing is 6. So you just take 16 times 6 and don't forget to divide by 2. Okay? Same thing on a kite. If you know the two diagonals, you just take this diagonal times this one divided by 2. And again, you'll have a formula sheet that has all these formulas on there for you. Just remember, if it does have a label, if this is inches, this would be 48 inches squared. Don't put the squared after the 48. That's wrong. That'd be counted wrong. The squared has to come after because this means 48 squared. Okay, then the only couple other things. If you have a trapezoid and they draw in the mid-segment. Mid-segment means this is equal and that's equal. If this is 6 and this is 14, you remember how to find the mid-segment? It's the average of them. 6 plus 14 is 20, divided by 2 is 10. It's halfway in between 6 and 14. So the same way, if they were to give you this, if this is 4 and this is 8, what would that be? 12. It's 4 from there to there, so it'd have to be 4 from there to there. Then the only other part is some you got to find angles. And sometimes you got to find sides. Okay, so remember, we're doing quadrilaterals, so sometimes they'll add up to 360. Like a simple one would be like this. If you got a quadrilateral, and this is 120, and this is 70, and this is 6x plus 2, and this is 80. You would take 360 and subtract these off to figure out what this is, and then it would just be 6x plus 2 equals whatever, and then you solve it. Okay? But if it's something like this, this is a rhombus. So what do you know about these two angles?
They're the same.
They're equal. So 6x minus 10 has to equal 4x plus 6. So then you got to solve it. Get the 4x over there, so you minus 4x. Get this over there, it's a minus, so you add 10. Then divide by 2 and you get x equals 8. But if it would be written like this, now they're not equal, but what are they? They add up to 180. So 6x minus 10 plus 4x plus 6 has to equal 180. Yes, be quiet. So 6x and 4x is 10x. Negative 10 plus 6 is negative 4 equals 180. So then you just solve it. Add 4, divide by 10. Now on these, what do you know about this side length and that side length? They're equal, so that's your equation. 2x plus 4 equals 6x minus 8. Now, and then you solve it just like before. So, the thing that sometimes people get confused is if it's a side length or if it's an angle. And they throw in, they get that stuck in their head that since we're doing quadrilaterals, they always add up to 360. That's only on the angles. Okay? When it's side lengths, it has nothing to do with 360 degrees. Everyone got that?
Yeah.
Okay. So that's everything. Yep, should be easy.